Okay, thank you, Parisa. And you started the recording. Good job.
I did, yeah. A little late, but I
Okay,
got it.
got it. Okay. All right. Success on high stakes exams with TI technology, SAT and ACT. Some of you joke that I've been teaching for 75 years, and that's true. I should probably be dead, but those are concurrent, not consecutive. All the materials for both of my sessions are at this website. Maybe Preezy, you could put that into the chat there, and I can put it in later, but it's all lowercase. It is case sensitive. bit.ly/T Cubed International Conference 2023, T3IC 2023. So all the information's there. So if you say he went too fast or whatever, all the questions are in a PDF. All the solutions are for both 84 and Nspire. Okay, so got all bases covered. And I'm probably not going to get to all of them, but you'll have other ones that we didn't get time to and have the solutions to those as well. All right, so my quotation, the only reason for time is so that everything doesn't happen at once, is my quote for today from good old Albert Einstein. Another favorite quote, I guess it's on my other one. I thought I had another quote that I like too. Yes, as long as teachers give tests, there will always be prayer in schools. That's my other quote. I don't know who said that, but I do kind of like that one. All right, so let's go ahead and start talking about the new digital SAT, because this is, we talk about new, I mean, the book just came out August 29th, less than, actually just a little over a month ago. Okay, and I bought it as it came out and have absorbed it, and I'm still don't feel like an expert, but feel pretty comfortable. So all my materials are from this, so that you know that's where it's coming from. For those who do SAT, I strongly urge you to download, install, and log into the Blue Book app. And this is where you'll find it. By the way, this information is on a PDF that you will get. So don't worry about copying stuff down. You'll get this, okay, as a PDF. So this is a place for you and your students to practice. Here's some key information. It's two-stage adaptive testing. I'll explain that in a minute. 44 math questions total in 70 minutes, about a minute and a half, a little over a minute and a half per question on average. The first half of it's 22 math questions, including 2 that are unscored, but you don't know what those 2 are. Second is also 22 with 2 unscored. Multiple choice is about 3/4. A fourth of it is what they call student produced response, or fill in the blank, or write your own answer, or whatever, short answer. For the first time ever, now we can have negative answers on the SAT, on the ones where you score them in or to write them in, on your computer sheet. Previous SAT, you never had a negative answer. There wasn't a negative sign to be used. Okay. Each question is standalone. There used to be sometimes there were 2 or 3 or 4 that went together. No longer. Is that true? These are the subject areas in context that they like to use. And the word count, about 30% of the questions are set in context, and most have 50 words or fewer, which is different from the SAT. They used to be very verbose. A lot of informational graphics, and as the old SAT, no penalty for guessing. Okay. Again, all of this information is on a PDF. You do not need to write it down or remember it for right now. So two-stage adaptive testing. Most tests are linear. You do 1, you do 2, you do 3, you do 4, and so on. On the new SAT, if after the first part, you do really well, you get a different test. If you do really poorly, you get a different test. If you do medium, you get a different test. Okay. The thinking there being, if you do really well, you need to be more challenged. If you did really poorly, what's the point of challenging you? We already know you probably aren't going to do well. Let's figure out where you are. They want to figure out where you are in the scheme of things. Okay. So it means that if you do really well and you go on to the harder test, you could get fewer questions right and have a higher score. I have no idea how they do that. They're just saying that they do. Okay. So this is, if you get that book, this is where you can get about adaptive testing and its fairness. Content areas, about 1/3 algebra, 1/3 advanced math, 15% problem solving and data analysis, and trig and geometry are now brought back up. They had been kind of cast aside for a while. They're now brought back up. Okay. Calculator options. Also, for the first time ever, graphing calculator can be used on every single math question on the new SAT and PSAT, by the way. Calculators are included that are acceptable just about every calculator that TI makes, including CAS, including Nspire, including Nspire CAS. Okay. And then also Desmos is allowed. It's embedded in there if you're doing the online part. ACT. Can use a graphing calculator on every question. That's been the case for a long time. 60 questions in 60 minutes, that's 1 minute per question, right? And the answer is absolutely no. If you're going to carve out a minute per question, you are not going to get finished. They are put together so that the first 20 are easy, the middle 20 are moderate, the last 20 are harder. Okay, not a hard and fast rule, but pretty close. So what we suggest is 30, 60, 90. What do we mean by that? The first 20, 30 seconds on the average, middle 20, 60 seconds, last 20, about a minute and a half. 30, 60, 90. Where have I heard that before in a math class? I'll leave that for you to figure out. So since the topics on the two exams overlap quite a bit, we're going to use most recent release ACT, SAT questions. They could just as well be on the ACT2. That's the concepts we're after, not the actual questions. So those who are ACT people, if you feel you're being shortchanged, don't. Okay, don't feel that way. I just wanted to hit out the new SAT parts. So just put this out here. For my students, I want them to be able to do these problems by hand without technology. That's my goal. Okay. On really tough problems, where it's applications and they have weird solutions, I do want to use technology. However, that being said, since this is such a high stakes exam, I want my students to feel very comfortable using the graphing technology quickly and effectively. So we're going to focus on calculator use today, because in 60 minutes, I can't tell you all the different things I can do, but I can focus on the calculator. But I want you to understand that's not my focus when I teach in class for the test, prepare for the test. It's part of it. Okay. So again, focusing on the calculator. All right. So you will have a PDF that has each of these questions in this order. So if you want to print that out and use them with your students, I highly recommend it. In fact, we highly recommend that you do at least one problem per day, either SAT or ACT per day, to help students prepare so that they get used to how differently the questions are asked. So for right now, this one says, which expression is equivalent to this? Of course, we're basically asking them how to factor this expression, okay? And so I'm hoping my students can factor this. I hope that this is not a difficult thing for them, okay? So what I would want them to do is, if they were stuck, go to y equals and type in that expression, x squared plus 3x minus 40, and go ahead and graph it and look to where the zeros are. And if I want to, I could even look at the table and see where the zeros are. So it looks like it's at positive 5 and at negative 8. Yeah, positive 5 and negative 8. And so once I've done that, let me go back to the graph. I can now go back and show them, since x equals negative 8, that means that x plus 8 is a factor, because I remember I start off x plus 8 equals 0, get x equals negative 8, I'm going backwards. X equals 5 means that x minus 5 is a factor, so there's my solution. I can see it in the graph, I can see it in the table. On the Nspire, if you're using Nspire, when I graphed it, you can find the zeros and see where they are at negative 8 and 0. So what I'm doing is I'm probably mostly going to show it on the 84, but I always have screens to show how to do it on the Nspire. So I don't want anybody to be shortchanged. Okay. So let me stop there for a minute. Questions, comments? All right. So if you have questions, or you say, well, could you repeat that, or go over it again, or how do you do this? Just put it in the chat, and Parisa will stop me, or else address it at the end. Okay. All right, number 8. What is the positive solution to this equation? Now, there are a couple different ways you could do this one, okay? One would be graphically, okay? So let me go to y equals and clear that out. And let me maybe make this a little bit bigger, but not that big, because then I can't see it. Okay, there we go. So I'm going to go ahead and put in, using the fraction template, 55 in the numerator and x plus 6 in the denominator. Enter. And x in the y2. Let me see what my window is here. Yeah, it's my favorite window. So I'll go ahead and graph it. And notice I have, looks like I have 2 points of intersection here. This one's over here. Remember, it says x has to be positive, so I don't need to worry about that one. I need to just get this one. And so I can go ahead to the second trace, which is the calculate menu, and number 5, intersect. And first curve is the blue one, enter. Second one is the brown one, yes. And my guess, I'm going to say the guess is the number close to 3. And there's my solution. And it turns out when x equals 5, y equals 5. So there, you can't almost miss this one, okay? So that would be one way to do that graphically. I'm hoping they could do this by hand, okay, by multiplying and so on. However, the other thing they could do is they could also use something that I don't like to use in my regular classroom, but on the ACT or SAT, I want this to be used, and that is the numeric solver. So on the 84, when I press math, press the up arrow, the last thing is the numeric solver. And it says expression 1, expression 2, so that's the left side, right side. I could type these. I'm not going to do that here. I have them in Y1 and Y2, so I'm just going to say alpha trace. I want whatever's in Y1 here, alpha trace, whatever's in Y2 here. And then you'll notice the word OK is really above the graph. In fact, if I do this, you can see it. It's above the word graph, so I'll press graph for OK. Now, this number right here, it says x equals 5, which is the solution, but that's not normally going to be there, okay? So it's asking me to put in a number for my guess, or say, find the one that's closest to x equals 3, kind of like I did before. And I don't press enter here. I press graph to solve it. So I put in my guess, and then I press graph to solve, and there's my solution. And you might say, well, it's not exactly 5. Well, it's using something like Newton's method, so it's not going to be exact, but it's going to be doggone close, okay? So those are the ways to do that with the 84. You can also see it in the table, okay? And then on the Nspire, this is the one I just did with the numeric solver. On Nspire, you could also do this graphically. Nspire also has an nsolve. And let me just show that real quickly for those of you who haven't done that before. So, oh, and by the way, if you have Nspire, I have both a file for just the questions. Here, you'll see that these are just the questions, okay? And then here are the solutions. And so it's showing how to get the solutions for each of these. So if you're an Nspire user, I'm not leaving you stranded at all, okay? So here's the nsolve. Where that is that's under menu. Oh, sorry. Let me make sure I'm getting the right thing here. Sorry. I was in the notes. I want to be down here and here. So it's menu. It's under 3 algebra, and it's numerical solve. And so you type in the equation, comma, the x, and then equals your guess, a number that's closer to 10. Okay. So that's how I got that. So let me stop there for a minute. Questions or comments about numerical solve or graphical on either one?
I don't see any questions so far, Tom.
Thank you. Good. Okay. And if I'm going too fast, you can let me know that too. Okay. Or too slow.
Sorry, I do have one comment, Tom.
Okay.
With the colored calculators, putting the original expression and 3 of the 4 choices in y-equal equations, using the table to see if any match, it allows students to determine which answer is correct. The original one, then the final choice is the answer. That was more of a comment, I'm sorry, than a question.
Okay. Yeah, so
using color.
Yeah, using using the table ask method, if you have answers provided, you could do that as well. Okay, radians to degrees. I'm not sure how many people know this happens. I mean, I'm hoping you can do this by hand, but if I go on the 84, first of all, let me, second mode is quit to get out of that application. If I want an answer in degrees, then I have to have this to be in degrees. So I'm going to change the mode to degree mode. All right. So I'm in degree mode. All right. And now what I'm going to do is I'm going to type in 16 pi radians over 15. So I'll get my rational expression thing. 16 second caret is my pi. I need to put the radians in there. And I can get the radians where it says angle, and that would be second apps. And the radian is the third option. So 16 pi radians down all over 15. And so what I'm saying is I'm going to type this in radians, but I'm asking the calculator to show it in degrees because that's the mode I'm in. And there it is, 192. Okay. Now I could just as easily have replaced pi with 180, 16 times 180 divided by 15 to get the same answer. Okay. But I'm just showing you, you can do that on the calculator. And that can be done also with Nspire. Okay, also with Nspire. So again, if I say I'm going too fast, right, I can't keep up, you're getting this as a PDF so you can see exactly what these screens are. Okay, so don't worry about that. They're there, showing you exactly where you need to be. Because I knew this would be too hard to do it otherwise. So here is radians. Notice I'm in degree mode. On the Nspire, here again, you have to be in degree mode. And one of the things on Nspire that I really like on the latest software last few years is if you want to change the mode, you just click on the word degree and it changes to radian, or click on radian, it changes to degree. So really, really nice to be able to change that. Okay. So here again, I'm saying 16 times pi radians divided by 15, and it's giving me 192. All right, systems of equations, okay? I'm hoping my students can solve this. Notice they're asked to find the value of y, and that's unfortunate because most students would subtract these and get the answer for x and think that was the answer. We call that never, stop at the halfway point, okay? But if you wanted to use this on the TI-84, it can solve a system, any system from 2 by 2 up through 10 by 10. And so let's go ahead and show you how you use that. Again, I could hope they could do this simple one by hand, but if they can't, it's perfectly legal for them to be able to do this. So I'm going to go to apps. And this is called the Poly-Simultaneous 2 app, okay, right here. And the second choice is Simultaneous Equation Solver. And notice you can set up a 2 by 2, a 3 by 3, all the way up to a 10 by 10, which, I don't know how worthwhile this is because I can't tell you how many 11 by 11 systems I've never had to do more than 4. So and also you'll notice when you use an app, if you're not familiar, they have these keywords at the bottom. They correspond to the hotkey that they're right above. So like if you want to go to main menu, press Y equals. I want to go on to next, so I'll press graph. And since I've not used this before, I just type in the coefficients, 24, enter. The plus sign, enter. I do need to put a 1 in place of the coefficient for y, and then a 48, enter. And notice it takes me to the beginning, which is what I like, 6. And I could type a plus or a minus. It's a plus. Again, a 1 and a 72. And I know some of you are saying, my students should be able to solve this by hand quicker than you typing it in. I don't doubt that, but if they want to be sure, or if it's difficult or whatever, they can. Once I've got it typed in, I go ahead to solve it, press graph, and there's the answer. So very, very nice. And the answer, of course, is 80, not negative 4/3. All right, so again, this is how I did it with the 84. This is how you do it on the Nspire. There's a command called linear solve where you just type the equations in and it gives you the solution. Riza, did you have something?
Nope, I just put the link in the chat to where they could download the PolySimul app and other math apps from the website if needed, and that this functionality is embedded on Nspire. No need to download and install an app.
Okay, good. So Inspire users, if there's something you're not sure that I'm showing you where it is, and that's not enough, please just say, hey, could you show me where it is live, not just a picture of it. So please catch me on that. All right, this is number 20. This says, given this function, for what value of x does this reach a minimum? Okay. Again, I would think to do this graphically, I would want to put it in vertex form and then see where the vertex is, and that would be the minimum because this is opening upwards. But remember, on the calculators, we can find minimums and relative minimums and maximums. So to get out of this, I have to go back to the main menu. So I'll press y equals. And then I have to press number 6 to quit the app. And now I'm out of the app. Okay. So I'll go to y equals and I'll clear what's there and type in this expression, 4x squared, and so on. And I'll go ahead and graph this. And you can see I can't see the minimum. Okay. So what I might want to do is change the window if I want to see it. And I'll maybe have my y minimum go down to maybe -50. Not sure exactly where it is, but let's see. And there. So now I have a pretty good idea. Okay. I could trace on it if I want to, but at this point, I'm going to use second trace for calculate and find the minimum value over an interval. So it's saying, what's my left bound? You can move this to get your left bound and right bound. I just like to type in the values. I'm going to say it's between 3, left bound, enter, and right bound, 10. Enter. And my guess, I'll go with a number in between like 6. And it turns out that this is my minimum, 6.24999, which is really 6 and a quarter. Okay, practically speaking. Okay, so that would be one way to do that. Another way to do it on the Nspire is the same thing, graph it, and then use the minimum feature, and it gives me in this type exactly 6.25 comma -30.3. So again, I'm using the calculator to answer the questions. I hope my students could do these by hand, but high stakes test, I want to make sure they have all the advantages. Also, you can do the numerical function minimum in the algebra menu. And so you type in the expression, comma x, and then it will give you the minimum, okay, which is 6 and a quarter. So there's 2 ways to do it on Nspire, graphically and just off the calculator screen. All right, here's evaluating a function. Boy, I wish my students could just evaluate this by hand and be done with it, okay? And I'm thinking most of them can, but how many of your kids are going to mess up 2 to the 3rd power? Just, and maybe add 9 wrong, who knows? So for this one here, what I suggest you do is go to y equals, I'll clear this out. I'm going to type in x, and then instead of using ℏ3, I like to use math3 to get the cubic, because I don't have to worry about getting my cursor back down on the ground. So math3 is my quick way of getting a 3rd power, plus 9.
Tom, can I pause you real quick?
Yes, you can.
Olga had a question, and I think you just did it, but if you can just say the key press real quick. So she wanted to know, how do you clear all your functions in y equal at the same time? Or do you do it one by one?
You do it one by one. I do have a program called Reset GR3 that does that and resets all the colors and resets all of the colors and and a really good grid. So that's available at the end. And I'll try to remember to point that out. Reset GR3 is a great program to do that. But otherwise, you'd have to do it one at a time. So Olga, there we go. All right, so here we have x to the third plus 9. I can evaluate this many ways. I could trace on this and go to 2. I could make a table and go to 2. In fact, I think I will do the table because I'm not sure many of you know this. If I go to a table set and use what's called independent ask, notice where I am. Doesn't matter where it starts, by the way. When I go to my table, somebody say, well, that doesn't help. It doesn't have anything in it. No, it's waiting for you to ask the values. And there I put in 2. I could put in negative 1.6. I mean, I don't have to be stuck with any particular numbers. So I really like the table ask mode. Okay. So that would be one way to do it. Table ask, trace on it. But my favorite is actually function notation. So since I have this in y equals in y1, I'll go off to the home screen and I'll bring up y1. And the quickest way to do that is alpha trace. And y1 is the very first one. And evaluate that left parentheses to right parentheses. So instead of saying f at 2, I'm saying y1 at 2. Okay. And so that would be my favorite way. By the way, they're also like to ask questions on doing composition of functions. And you could do that too. I could do y1 of y2 of a number or y2 of y1 of a number, all on the calculator. Okay, so keep that in mind. So how did I do this? So this is how I did it with the 84. How did I do it in Nspire? Now, Nspire, I don't know how many of you know this, you can define functions. So maybe let me show that because that's not something that all people know. So this is the one that has the solutions. So to define it, so if I'm down here and I'm going to define, it's under, I'm in a calculator page. It's under menu. It's the very first action. It's the very first command is define actions and define. And then you just type f of x equals g of x equals, and you can have functions with more than one letter name. Okay. You could have VEL for velocity of x and so on. So, all right.
Can I stop you there for a sec, Tom?
You sure can.
Colleen wants to know, and I think you kind of touched on it in the beginning, but are there any specific test taking strategies in relation to it being digital now?
I don't have any right now because I haven't done it, but that is something we're working on right now. I I really wish they were still paper and pencil. Of course, I'm really old, but I need a pencil. I need to write on things. I think it's really hard to see them up there on the screen. Okay. But unfortunately, I don't have any digital ones right now. I have lots of other ones, but not strictly for digital. So sorry. So I'll give you a Pez because I couldn't answer your question. So Halloween Pez coming up. All right, so here's one that I'm not sure many of you use 84s are aware of this. This is I really think this is kind of clever, and it just looks like it's going to be a mistake happening. All right, I'm hoping my students can do absolute value inequalities. I do, but if they can't, here is an option. Okay, so I'm going to go to y equals. I'm going to clear what's there. I'm going to type in this inequality as you see it, except instead of z, I'm going to use x because that's the only variable you can use in the grapher. Okay. So I'm going to type in 2. And then for absolute value, that's under alpha window. Alpha window has all the cool templates. 3 minus, and instead of z, I'm going to put in x. Get out of there. Plus 8. Now to get the inequalities, those are under the test menu. So second math is test. And any less than or equal to is the 6th one down. And then 20. Let's see if I type that correctly. I type that correctly. Yeah. Now this, when I first did this or saw this, this looked like a mistake waiting to be happening. Okay. Mistake waiting to be happening. So this is the window I'm using. This is like my favorite. Oh, you know what? I did change this. Let me make this negative 8.2. And somebody said, well, why that one? I'll share that with you in a minute. But let me go ahead and graph this. And notice it's showing me where it's true at y equals 1 and where it's false at y equals 0. In fact, what I could do is if I wanted to just see it, I can actually go to the format and detect asymptotes on, and it'll show it just as a bar graph, basically. So when I trace it, it looks like at -3 is where it starts, and +9 is where it ends. And that's going to be our answer, letter B. So I really think that's a cool thing on the Inspire. Okay. I'm sorry, on the 84. Inspire does not do that, by the way. I'll explain real quickly why this works. It's using something called Boolean logic. Boolean logic, if something is true, it's 1. If it's false, it's 0. So where this inequality was true, that is graphing y equals 1. Where it's false, it's graphing y equals 0. I turn these off so I wouldn't have them connected. That was the reason I turned them off. On rather. Normally, I like to have them off. On the Inspire, what I could do is actually graph this in relation mode, and it's going to graph it as the absolute value, and then graph y equals 20 and see where they intersect. So it's from -3 to 20 right there. Not as nice on the Inspire. All right, here we have a quadratic linear system. Okay, so one way to do this, of course, would be to solve it graphically. Okay, graph the first one, graph the second one. I'll leave that for you. This is also another one that's just tailor-made for the numerical solver. So let me go back to math and to numeric solver. And this time I'm going to clear that and type in, as you see it, the quantity of x minus 2 times the quantity of x plus 4. Then y2, I'll clear that and type in the 6x minus 12. So there's my, let me go back up so I have that. So that's what that's going to look like, okay? And then I'm pressing graph because I'm saying, yeah, that's okay, okay? All right, so this is my guess. And notice which order pairs. So my numbers have to be around 0, 1, 2, and so on. So I'm just going to guess 1. And again, you don't press enter here. You press graph to solve it. And so I'm getting 2.000. It's close to 0. So what I have to do is now go back and put in 2 into either one of these equations to find out what the corresponding y is. And it turns out if I put it in 2, it's 0. And if I put it in here, it's 0. So C is the correct answer. So I use the equation solver, the numeric solver. And I'm outlining what your guess is and the solution. On Inspire, I actually did it graphically. I graphed the quadratic, graphed the line, and it looks like it's tangent at 2, 0. So I use the intersection tool to find it, the answer to be at 2, 0. This one does give you not only the x, but also the y coordinate. How we doing, Parisa? Okay?
Yes, yes, thank you.
Okay, again, give me questions. I'll be happy to answer them. I also did NSolve on the Inspire, okay? Just like we did with the 84. Again, this is the syntax for that. And then I had to actually find out the corresponding y. All right, so radical equations, these could be solved graphically. Okay, I could graph both of these and see where they intersect. In fact, I think maybe I'll do that. So I'll go to second mode is quit to get out of that. I'll go to y equals and clear that. I'll type in this on the left-hand side. So second square root. Again, I do need the parentheses. X minus 2, the quantity squared. That'll be my y1. And my y2 will be the square root of that linear, 3x plus 34. And I didn't do that very well, did I? Let me clear that. Oh, that's weird. Second square root. And then I'll go ahead and graph this. And you can see I'm getting 2 points of intersection, okay? And somebody might say, where are you getting this absolute value from? Okay. Well, remember, the square root of something squared is the absolute value. Okay. It's just moved over. Okay. And this one is a radical, which of course is half of a parabola. Okay. Opening to the right. So it says, which is the smallest solution? So the smallest solution means the x value, and that means the one that's right here that's negative. So I can go ahead and go second, trace or calculate. Number 5 for intersect. First curve, enter on blue, enter on brown. And my guess, I'm going to guess around -5. Get the one that's close there. And there's my solution. So -3 is the answer. Okay, that's the smaller solution. If I wanted to use the numeric solver, what I like about this is I can clear out, I don't have to type it in because I already have this in Y1 and this in Y2. So it's kind of like a double check. So Y1, clear, alpha trace, Y2. And then graph for OK. And again, I'm going to guess -5 for my solution and then press graph for my guess and then graph. And there's my solution of -3.
Tom, we have a question about numerical solver that they struggle with using it because it only gives one solution. Is there a way to see both solutions?
So the answer is no. There's no way because to do that, the reason you have to give it is just because you have to say which one do you want closest to. So for example, let's say you had a sine curve and you had y equals a half. There's an infinite number of points where that happens. So you have to say which value, which one do you want? Do you want the ones closer to 0, pi over 6, pi over 2, 3, -3, whatever. So no. On Nspire, you can do it graphically. So I will show that. So that's a good question. But for on the numerical solver, on either one of them, you have to give it like a seed to look for. Okay, and that's true of anything. Even the Newton's method asks you for a initial guess. But good question. Good question. So again, that's the way I just did it. Here's the Nspire. I did it graphically, and I found both of those solutions. And here's the numeric solve. And I said my guess was 0 to get -3. My guess was 20, and I got 10. Okay, so that's how you can do that. Let me show you how you can get multiple solutions on a graph on Nspire. It does not work on the 84, but let me show you that. Hopefully, at least get you something. So, so let me insert a graphs page, and let's do something simple like x squared minus 5. And let's go with 2x minus 3. So there are 2 points of intersection there. If I wanted to find them both, if I use the intersect tool, I can only find one. But if you use the geometry tool and use intersection points, you click on the first, you click on the second, and notice when I clicked on the second, it showed me both points of intersection at the same time. So there's a way to do it. And if there had been 3 or 4 or 5, would have seen them all. The other thing I like about Nspire also that the 84 can't do is that you can change, if you change the equation, if you do this on the 84, you lose everything. If you change it on here, it just updates and still finds the points of intersection. So if you knew that or not, but no extra charge, just throw that in. All right. Here's another one. What's the positive solution to this given equation? Okay. Again, graphically could be done. The numeric solver could be done. In fact, I'll just kind of show that there. So here again, you just type in the left side, type in the right side, give a guess, and I got 2 1/4. You know what? I probably should show this one. Wait, I'll show the next one. I'll show the next one. On Nspire, numerical solve. And this one here on there, you can do what's called the approximate fraction tool and say, get your last answer and approximate to a fraction so you can see that. I'll show how that's done on the 84 as well when I get to the next problem. Yeah, because I wanted to illustrate this one. That's the reason I did that. So sometimes they'll ask, what's the sum of the solutions that give an equation? The reason for that is they could say, here, here's 4 answers or 5 answers on the ACT, which are the solutions of the equation. You can just substitute to get them. But here, they're asking you not only to find them, but to add them. So do you know how to, so you have to find them both and be able to add them. And they might be fractions or negatives or decimals or whatever, okay? So for this one here, let's go ahead and look at that. I'll go back to this and clear, and I'll use the numerical solver. But I want to illustrate something different with this, okay? And then here on the other side, oh, forgot the minus 56. Minus 56. And 4x. All right, so let me go back again. So this is, looks like I typed it correctly. So I'll press graph for OK. And I'm just going to go ahead and type in 0 as my guess and then solve. And I'm getting this number here. Okay. Let me pull that off better. And now we know what that number is, but unfortunately, many of our students don't know what that number is as a fraction. And somebody say, well, it should really be a 7 here. Okay. So I'm kind of curious if it's going to give me the x fraction. But here's the thing I want to get across. The value of x is stored in x. Okay. So when I leave this, second mode is quit, and press X, there's my value for X. And notice it's putting 7 because it's showing fewer significant digits than it did over here. So what I'm going to do is say, I want you to convert that to a fraction. And alpha y equals is where the fraction templates live. And number 4 is if it's a fraction, make it a decimal. If it's a decimal, make it a fraction. And so enter. So take that last answer, convert it to a fraction if you can, and there it is, 8/3. Okay, so I think it's very important that you realize that when you find a value of x there or a value of x on an intersect or something like that, it's stored in the variable x, and then you can convert it to a fraction or back to a decimal. Or in fact, you can even make this a mixed number. So alpha y equals number 3. Take the last answer, which is 8/3, and convert it to a mixed number. And if I hit it again, go back. And I can go back to a decimal and so on. So anyway, I found one of them. Let's go find the other one so that we can find the sum. So again, I'll go back to math, and notice I'm going up arrow to get to the bottom quicker. And okay, and this time, let's maybe see if there's one closer to 10. I'm not sure. If it isn't, I'll go the negative direction. So that's and 7 is the other answer. And so now I'll go off to the home screen and type in x, which is 7, plus I'm going to go up here and grab the 8/3, enter, and there's my answer. So I'm using the history to find or show values. I'm using the calculator to do the calculations for me. By the way, I like that. I hope all of you are using it or will start to use that. Questions or comments?
I don't see anything new yet, Tom.
Okay. So there's 84. This is the Nspire version. Okay. And notice how I can use the approximate fraction tool there. All right. So for this one, this is a system. Okay. And I could use the system to solve this. But on the 84, I would have to type it in standard form, x plus y equals something, x plus y equals something. Okay. But on the Nspire, I don't. I can type it as you see it. Okay. So, but so this is it on the 84. Okay. We've already done it. That's why I'm not doing it again. So I getting 1, -2. Okay. On Nspire, notice I'm just typing it as you see it in the linear solve, because it allows you to do that and it's saying solve for x and y, getting the same answer. But what I want to point out is SAT, especially more than ACT, has this happen. 2y plus 3, 2 times the quantity 2y plus 3, that's 4y plus 6. If you notice that and just substitute, you're done in like 3 steps. And this is something called using structure. Okay, using structure, the structure of algebra. I'm going to show a couple other things there on that. This is a huge thing for students to do because it saves time. And what's the most important thing on the SAT and ACT? Well, if you said time, that would be second. Knowing the math is first, but time's way up there. Okay. All right. Here's one that's kind of nasty. This is a nasty equation. This is not one students would want to solve by hand, but they still could get it. It's just they'd be skeptical that they would get the right answer because of the fraction. Okay. So again, when I did this, notice I'm getting such an awful decimal, but again, I can convert it right to the fraction. Okay. So be aware of that using the numerical solve. And similarly on Nspire. All right. And then by hand, this is what it looks like by hand. All right, so here's number 24. I'm getting down close to the end now. I have, I think, about 3 left. And then we can take questions. And I want to show you where all this good stuff is. Okay. So here, with all these decimals and everything, kids are going to, panic and not be excited or, but again, you can use the calculator, which is perfectly okay. All right. And I'm coming up with an answer of -8/10, which we can convert to -4/5. We can also use numerical solve here. But what I'd like you to realize is you can also use this thing called structure of algebra. You'll notice I've got -2 of these guys equals -3 of these same guys. So what I can do is add 3 of these guys to both sides to get 1 of these guys equals 0. And now it's not very difficult to solve. So most students, when they see parentheses, distribute. And in most cases, that may be the case. But this is using structure. And again, SAT loves to have problems on there like this. This is how they separate students from the very best to the not so very best. All right, number 25. Let me think on that for a few seconds. Go ahead and think about, see if you can come up with at least 2 different ways to do this. Okay, at least 2 different ways to do this. Let you think about it. All right, so I'm going to show you when we have SAT and ACT prep that TI's developed. I was one of the co-developers of it. And when I field tested this, I have 25 kids in the class. 24 of them did this problem this way. Okay, so they started off with the quadratic and the linear. It's a linear quadratic system. They solved for either X or Y. It didn't matter really. Substituted for X, had to square the binomial correctly, by the way, saw that the y squared made 0 and got y equals -2. But we're not done. We still have to go back and find X. And so we found X to be 10. Still not done. We have to subtract those and finally get 12. 24 out of 25 kids on the average did it this way. Why? Because that's how we've programmed them to do it. Okay. By the way, the numerical solve is no help here whatsoever because it has 2 variables. The linear system is of no help because it's not linear. Okay. However, many of you probably came up with this idea. You factored this and replaced X plus Y with 8 and divided both sides by 8 and got 12. So which would you rather do? This or this? And I have to tell you, the students were pretty mad at me when they saw it. In fact, they were mad at their teachers saying, why didn't you show me this? Okay, so I highly recommend it. And even though I showed them this, I got to tell you this. I got to here. And when I went to this next step, I had kids turning and looking back at their teacher going, is he allowed to do that? Like, you have that 8 there. Normally we distribute that. Like they'd write 8x minus 8y equals 96, which is of no help whatsoever, but that's what they're programmed to do. Okay, so we need them to think outside the box using structure. Okay. And then finally, I just thought I'd throw this out here. If I ask students, you might have to factor something like this. And this is where I strongly encourage my students to factor by graphing. I really encourage them to do that. So x math 3 gets me the cubic, minus 2x squared, minus 11x, and then plus the 12. Type that correctly. Looks like I did. And now I can go ahead and pull this off. And by the way, if I'm not sure where the zeros are, I really like to use the graph table mode. And so I'm going to go down to the full mode and over to graph table. And if you've not used that before, I highly, highly recommend it. I'll have my table start at, let's say, -5, and everything should be automatic. So now I'm going to go to graph table mode and make this big. And so now you can see, as I'm going through here, there's definitely a 0 at -3. There's definitely a 0 at 1. There's definitely a 0 at 4. So I'm getting x equals -3, which means x plus 3, x equals 1, x minus 1, x equals 4, x minus 4. Beautiful, just beautiful. And I love this graph table mode to be able to illustrate that. All right, so with that, I think that's, again, we could also do it on Nspire. This is the website that I created for you guys, and I want to take a couple minutes. If you have questions, get them queued up in the chat so that I can answer them. So this website here, let me show you all that's there. There we go. So I did 2 sessions today. Earlier, I did this on 27 clever activities on the 84 plus. You're welcome to use any of this information here. Okay. This is what I did: high stakes exam, SAT and ACT with TI technology. This is a PDF of the sample problems that you can download and print out with your students. Okay. So here we go, right there. So these are the questions in order that we did them. So you're welcome to print that out and use those with your students. The other thing that's there is the solutions are there. So these are the solutions. These are my slides that I just did with you guys. And so the solutions there, not just on the 84, but also on the Nspire. So you have those too. Okay, I'm trying to make this as easy as possible for you to use this. The info about the new digital SAT, that's this PDF right here that I discussed earlier. You now have it. It's yours. Okay, these are active links, by the way, on the PDF. The 2 Nspire files with problems and solutions, they're right here. You do need to download them, unzip them, and then you can put them right on in your Nspire, and then put them on your kids' handhelds if you want. Okay, so those are there. As a bonus, I'm really big on families of functions. TI has a website on families of functions that will show you how to graph, has 250 plus videos on how to graph all the main parent functions and their transformations. But to me, the cool thing is this PDF. Okay, if you download, give this to your students to download, you can just say, let's say you're teaching linear, say, if you don't know how to graph this, click on this. It'll show you a quick YouTube video on how to graph it completely. If you want to do quadratics, any one of these, absolute value, you just click on the video and it'll show it, and they can go through as slowly or as quickly as they want. Okay, they're all there for you to use. So there's the website, there's the PDF. If you have any tech support you need, 1-800-TI-CARES. They're literally at some of their homes waiting for you to call them. And if you need to know who your education technology consultant is by state, click here. You can contact that person by phone number or by click on here and you get their email address. Parisa is a person who's there right now. She services these states and regions of Texas. So one-stop shopping right here. Hopefully this worked out for you. If you have questions, Parisa will give them to me. Otherwise, thank you for coming and hope to see you somewhere else.
Tom, I have one question, and if everybody has the last minute to hang on, I'll go ahead and cover it. Before I do, I want to announce who the winner is. I used a really pretty random generator. I asked my 5-year-old to pick a number between 1 and 78, which is the number of participants we had, and she picked the number 10 twice. So Betty Clark, you are our winner.
Congratulations.
So, and she can count to 100, so don't feel like you were discounted. She can get up there. But Tom, one of the great questions I saw at the end was, when do you suggest showing this to your students that they really struggle with, like showing them how to do stuff on the calculator versus paper pencil? Like, when do you introduce this?
So that's a very good question. When you're using technology, when I started using technology, and it's 30 years ago this year that I started using graphing calculators in 1993, I had to change my assessments. My assessments are 2 parts now. There's green go calculator and white no calculator, because there are certain things they could do on their calculators, and that's not what I want. I want to know, do you know how to do it by hand? So I will show them how to do things on the calculator, but come my test, they may not be able to use it on that part. So they have to know how to do it by hand, and I'll tell them you have to do it by hand, be able to do it by hand. Or if it's really difficult, or if it's an applied problem or answers are like 24/7 and whatever, then they can use it. On the ACT and SAT, since they're allowed to use it now on the whole test, they need to feel comfortable with that. They can't be told the day before, this is how you do all that stuff. It's not good. So you control when they use it, and that they don't become calculator dependent. Does that sound like a good answer, Parisa?
Yeah, that's great. Thank you. Thank you, Tom, for everything you shared today, all the resources, the links. You will receive a survey link after this session, and we got another one coming up. So thank y'all for being here with us. Bye, everybody.
Bye.